Hello everyone. This video is about features of MQTT. Now, let us see the agenda for the discussion in this video. The presentation will start with the discussion of quality of services, written messages, birth and death messages, and last will testaments. So, let's get started. The first feature is quality of service. MQTT protocol specifies the quality of service which guarantees the reliability of message delivery under different network conditions. There are three QoS levels in MQTT: QoS0, QoS1, and QoS2. QoS allows the client to select the quality of service that best suits its network reliability. Let's discuss first one, QoS0. It is also known as at most once. This is the simplest and lowest overhead method of sending a message. The client simply publishes the message and there is no acknowledgement sent by the broker. The message might be lost if the client is disconnected. QoS0 is the fastest mode of transfer and it's sometimes also called as fire and forget. Next is QoS1, which is also known as at least once. QoS1 is the default mode. This method guarantees that the message will be transferred successfully to the broker as the broker sends an acknowledgement back to the sender. But in the event that acknowledgement is lost, the sender won't realize the message has got through, so will send the message again and again. The client will resend until it gets the broker's acknowledgement. This means that sending is guaranteed, although the message may reach the broker more than once. Next is QoS2, which is also known as exactly once. QoS2 is the highest level of service in MQTT. This level guarantees that each message is received only once by the intended recipient. It is the safest and slowest quality of service level. The sender and receiver use the packet identifier of the original published message to coordinate delivery of the message. When a receiver gets a QoS2 published packet from a sender, it processes the published message accordingly and replies to a sender with a public packet that acknowledges the published packet. If the sender does not get a public packet from the receiver, it sends the published packet again and again with a duplicate flag until it receives an acknowledgement. Then the sender stores the public packet from the receiver and responds with a pubrel packet. After the receiver gets the pubrel packet, it answers with a pubcom packet, which indicates that the publish has been completed. When this flow is complete, both sender and receiver are sure that the message is delivered and the sender has confirmation of the delivery. Next feature is return message. A return message makes sense when you want newly connected subscribers to receive messages immediately without waiting until a publishing client sends the next message. Let's assume that we have a one device here and this is publishing on, let's say, the topic MOOC/temp, and one device here which is seeing the same topic. So as long as this device is subscribed to the topic, it will get all the information that this particular device is publishing. But what happens if a new device wants to subscribe to that particular topic? And let's assume that this device is pushing data every 30 minutes and this device just now published a message to the broker. And the new device who is just subscribed now is subscribed to the same topic after 25th minute when this device has published the data. Then what happens is the new device will not know any information about what the latest information was. But this device is continuously subscribed to to that particular topic. It will continuously get the information and it has the latest information with it. So a return message is there, which is a normal MQTT message with a return flag set to true. The broker stores the last return message and the corresponding QoS for that topic. So each client that subscribed to a topic that matches the topic of the return message receive the return message immediately after they subscribe. Next is death message. So it is useful with respect to checking if the particular device is still alive or not. Let's say there are two sensors which are continuously publishing the data, and if one of the sensors goes down, then how do you know? So that can be directly understood by checking the status messages. So there is a birth and a death message, and this is pretty much happening whenever there is a new connection or disconnection done by the particular device. For example, we have a broker and there are two sensors, and these two sensors are continuously communicating with this broker. So sensor 1 connects, it gets an acknowledgement, and this sensor is publishing data on sensor 1 slash status. Then we have another sensor, sensor 2. It connects, it gets connection acknowledgement, and it is also publishing data on sensor on topic sensor 2 slash status. So this is the connection cycle that basically happens with every device that is communicating with the broker. So what happens is, when you are trying to subscribe to the particular topic, for example, sensor 1 is publishing on this particular topic and sensor 2 is publishing on this particular topic. So what happens is, we subscribe. So if you see here, there is a device and there is a console. So these two are going to subscribe to this particular sensors. So the first device is going to subscribe on that particular topic, and the topic has to be the same. So if the sensor 1 is online, it gets an online message. So this is what called as a birth message. So the first message on the subscription will be telling that it is the particular device is online. Similarly, this particular device is subscribed to sensor 2, and it is also says that the sensor 2 is online. So this is also indicates the birth message. What if sensor 1 disconnects voluntarily? So there is a disconnection. It went offline, right? So if it went offline, then since this particular device is subscribed still subscribed to the same topic, which is with respect to the sensor 1. So if sensor 1 goes offline, there will be a message that says sensor 1 is offline. So this offline message that is received by a particular device is called as a death message. So it's very simple. On connection, it gets a message saying device is online, and on disconnection in the sense the sensor has disconnected from the broker, and then that information is shown as offline. So this is your death message. So next is last will testament. So this is the most useful feature. So what happens is, let's assume for some reason if a wire has been cut, which is hardwired to particular controller, which is taking care of the data, or if it is a sensor that is being run by a battery and the connection to the battery is gone off. So these are the abrupt disconnections. Abrupt means broker does not know anything about sensor going down. In the previous death message, we saw the sensor did disconnect and let it broker know that it has been disconnected. But in this case, there is no such information sent to the broker. So what happens is, at that moment, what the broker normally does is, there is something called as keep alive time. So the keep alive time, depending upon what the time in seconds, it sends a ping request to all the sensors who decided to publish the data. So let's say if keep alive time is 20 seconds, so the broker sends a ping request every 20 seconds, and if there is no response received from the sensor, then it sends a last will testament message to all the devices that the particular sensor has been disconnected. So this is an abrupt disconnection, and how the broker knows, by sending a ping request after every keep alive time. So that's all. So in this video we learned about various MQTT features. In the next video we will see a small demo using eYIC framework. Thank you.